Good day, everyone. I hope that you are doing well today. Welcome and thanks to join us very much in today's webinar. My name is Giorgia Rossi, and I am the International Sales Manager at Jaxel, a company who is in the global market of 3D technology solution for many years. I'm excited to introduce today's guest, Mr. Sorush Kamyab and Mr. Petter von Kroll from WIESO. I hope that I have pronounced well your name, guys. And with Sorush and Petter, we will move to Norway today, experiencing a smart project in a tunneling railway site. So Sorush and Petter, thanks guys pretty much for this chance. Would you please introduce yourself and your company?
Hi guys, my name is Sorush Kamyab. I'm the CEO of WIESO. I'm here today with my colleague Petter von Kroll.
Hello everyone, thanks for having us. WIESO is a Norwegian-based consulting company, and we specialize in using 360 capturing and 3D scanning. And besides the capturing itself, we also try to help our customers to make use of 360 and 3D data to make customized digital solutions.
Thank you very much, guys. Just a few words about Jaxel, if you have never met us before. Jaxel is involved in the global market of 3D surveying and 3D mapping for more than 10 years by developing and providing innovative point cloud processing software and a survey system. Before we get started, a few information about how to join today's webinar. Please note that the audio portion will stream through your PC, laptop speakers. Be sure to check your speakers to ensure that they are turned on and that volume is at an audible level. Please enter your questions in the chat box. If you might have any kind of technical difficulties, try refreshing your screen, and we also recommend somehow to change your browsers. This webinar will be recorded for your reference, and you will receive it by email in a few days. At the end of the webinar, we will be at your full disposal to answer to your questions, but do not hesitate to contact us also afterwards by email or chat or phone for any other issue. And in case we might not be able to reply to all your questions, don't worry guys, because we will follow up afterwards. So let's move through today's agenda. After a brief introduction of the success case, we will focus on needs and goals, moving then to the technology used and entering in the core of the webinar, the post-processing data workflow. Sorush and Petter will comment the results, describing how did they reach out them, and we will then have some times for comment for a Q&A session. So now I am very glad to move to Norway. Petter, can you please describe where we are and who are the project actors, please?
Yes, thank you, Georgia. As you can see on the slide on the screen, as I mentioned, we are based in Norway, and this project is also situated in Norway, in the northern part of Europe, more exactly pretty close to Oslo, the capital of Norway. And you can see the white dotted line with Oslo on the right there. The white dotted line is the railroad tunnel that we will present in this presentation. The project has been ongoing for a while. WIESO, we have been working with it since, well, the last year. And the mounting of the objects that are being produced as a result of our work is being mounted right now as we speak. They did the first portion of it this Easter, and now in the summer the whole tunnel is closed for all the components to be mounted. The customer, well, our customer buying our services is named Power On, and the owner of the railroad in the whole of Norway is Bane NOR. And Poweron provides products and services for both rail and power generation. And Bane NOR is the state-owned company responsible for all Norwegian national railway infrastructure. And I should also mention that Poweron has 4 agencies from European suppliers, as well as its own products to supply, especially Bane NOR.
Okay. And can you, Petter, also provide some information, some details about the site in which you have work?
Yes. In Norway, there are a lot of tunnels due to all the mountains we have here, more than 700 railroad tunnels. And this one is called the Lieråsen tunnel. It's one of the longest tunnels and with most traffic. The length of the tunnel is approximately 11 kilometers. Its height around 6.5 meters, varying obviously since it's inside the mountain, and the width approximately 9.5 meters. And as I mentioned, there are a lot of traffic. More than 400 trains are passing through the tunnel every 24 hours. And as you can see on the picture also, there are 2 tracks inside the tunnel.
And also, I think that it's really interest this kind of project, because normally, of course, tunnel are always, how to say, a warm topic, and that's really, I think, interest. And can you also provide some, how to say, some details about the construction of the project?
Yes, inside the tunnels, the masts hang from the ceiling, and from this mast you have, on the picture on the right, you can see the mast hanging from the ceiling and the cantilever. And at the end of this cantilever, you have the power line that gives the train electricity. And our working aspect for this project was to first localize what we call as points of interest. And these points of interest are where the foot of the mast is placed. And after localizing these points of interest, we have to help Poweron to prefabricate the mast. And by doing this, we have to find the points of interest, find the correct height, and give this information to Poweron for prefabrication and customization for assembly for over 500 masts. And this challenge was best solved in 3D.
I can also mention, since you are an Italian company, pretty funny that the cantilever that you see on the picture is also Italian. It's delivered from the Alstom Italian group and assembled by Poweron and customized.
Yeah, thank you. Really, thank you very much for this explanation, because I personally have learned a lot, okay, organizing this event with you, and also, I mean, analyzing your project. So really, thank you very much for this project introduction. I also think that the attendees has understood more about this project that is pretty huge, but also I think pretty innovative for the technology, not only for the survey technology that has been applied, but also for the goals, the final goals, the final construction goals of the project itself. So I would like now to move a bit more in details into the core of the story. So I would like to focus on the needs and goals. And as you mentioned before, there were some interesting reasons that drove the client to choose the geospatial technology. And could you briefly underline why and how this has made the difference in this project?
Yes, we were connected to the project when there already existed data, point cloud data for the project. We always look for as much data as possible when we are doing projects, because then we can verify the different scans and kind of all the way being working with the most exact data. For this project, we had 3 types of point cloud data. We had aerial LiDAR scan, we had mobile mapping LiDAR scans from train, and we also used some terrestrial scanning. We needed several point clouds for this project, partly because of challenges with a new set of tracks that were installed during the project, and there were slight differences between the former and the new tracks installed. And to make sure our measurements was right when measuring from the tracks up to the ceiling, there was obviously need for a point cloud scan after the new tracks was there. Because, as I mentioned, slight differences in track position is very important to detect when you're working with the masts that will be installed in the ceiling. And we were really happy to have these 2 mobile mapping scans from train, because the ability to compare them is invaluable to make sure everything is right, and then we can detect any changes down to very exact measurements. And once we had all the data needed, then the localization of points of interest started. As Soros mentioned, the bolts in the roof or the ceiling for the upcoming masts was what we were looking for.
Yeah, and these points of interest consists of visual inspections in the point cloud, where we actually find bolts that were drilled into the ceiling. Besides that, we also get a set of coordinates for where the bolts were going to be drilled in the ceiling. And when we didn't have that, we actually had to measure between points to find out where the new bolts were going to be placed. So we had a different variety of input to find and pinpoint these places in the point cloud. And after the localization of all these points of interest, we had to extract many cross sections, 500 plus. And to be able to do this within a reasonable time, we were introduced to the mining add-on tool within the Reconstructor software, which was really helpful. And after localizing and extracting these cross sections, we had to make our deliverables the way Poweron technical drawers wanted them. And in this case, we ended up using the orthophoto, which was scaled with measurements, and we also extracted every individual point cloud for each mast.
Okay, thanks a lot, Soros. So we can say in a certain way that thanks to the 3D data analysis, you were able to carry out the project faster and easily in order to obtain the complete 3D model of the site, because as Peter mentioned, you have used a different kind of technology, and then multiple cross sections in defined point of interest, as you saw underline, and these cross sections are ready to be imported in CAD, where the mast with custom cantilever have been integrated to check their mounting feasibility. So I assume that of course, as you mentioned, you have used different kind of instruments, so different kind of technology to get your 3D point cloud. May I ask if you could, Soroush, explain a little bit why you have used, of course, it's clear why you have used a different kind of technology, but why you have decided to use this kind of technology, so the aerial, the mobile, and also the terrestrial one?
Yes, in Norway, aerial LiDAR scan of the whole country is available for free. And we use this data to enrich our projects with more environments. It's great to see a wider range of terrain than only what the mobile mapping system can catch from the railroad. This material gives great visual enrichment to especially tunnels, bridges, and etc. We also use this data to check the absolute tolerance of the mobile mapping data that we receive. If there is anything wrong with the georeferencing, it's easy to detect. With the mobile LiDAR, which is the main source of data for us, this is the data that we use to extract all the needed material and make all the cross sections from. And as Petter mentioned, we received two scans from the tunnel with 10 to 12 months interval in between the scans. And finally, the terrestrial data, we wanted to make sure that our measurements were as accurate as possible and that we got many verifications as possible. So thanks to Reconstructor, we could easily compare the different data from different scanners, put them on top of each other, do some calculations, and see which of the devices had what tolerance and what it actually meant in the scenario that we used the equipment in.
Okay, thank you. So we can say that the very first challenge has been to merge and manage all these different data together, and then, of course, extracting the desired output. And this is even better if all these job can be run in a single software platform, because you can, I mean, concentrate all your efforts and your job only in one software. And I think that here we come to the warmest topic of every 3D point cloud project, not only of this one, that is finding a smart software which could support end-to-end the entire job. And I want to mention that you have successfully used for this purpose the Jackson Reconstructor software. And I'd like to ask you, how did you find out this solution? And could you explain also to our attendees, why did you choose Reconstructor and what kind of benefit have you reached out by using the software?
Yes, we were introduced to Reconstructor by a Danish company that we worked with on a building scanning project, where we were several companies involved and we had several types of scanners doing the work. We were looking for a software that were non-selective to what kind of scanners that were used. And it needed to handle different point cloud file formats and combine them. Often the software is very good for some formats, but not for all of them. As this slide shows, the 3 point clouds here are from 3 totally different systems. And we have all imported them to Reconstructor, which handles them very good. Also, we found after working a lot more with Reconstructor that the stability of the software while handling large amounts of data was also something it did very well, and that is a criteria that was very important to us. As many of the attendees know, the size of the files, point cloud files are often very large, and I think many have experienced software that just crashes. But Reconstructor worked very well for us, and it met our most important criteria. And it's like after that we haven't really looked back, as Reconstructor has worked for us. And also I must mention that the ability to make contact with GXL when we wonder about something, or we maybe need help to get further, or we want to mention new stuff that we want to be put in the next versions and so on, has also been a big value for us, that we can have this one-to-one relationship with developers at GXL. So it kind of organically developed into our most used point cloud software along the way.
Yeah, many thanks, Petter. Really, many thanks to you guys, because I remember that we have spent some session, of course, after understanding your needs and goals. That would be pretty interesting also for us, because as you said, we could also try to implement and customize the software, okay, based on what you were looking for. And so we think that this, how to say, mutual exchange of information has been very useful in order to support you in creating a customized and also flexible workflow for your need. So we can say that, just to summarize, you have benefit of one of the strength of Reconstructor software, that is importing data coming from different kind of survey instruments. And let me add also that Reconstructor supports the direct import of most of the common point cloud raw data, such as Faro data, Topcon, Rigel, ZNF. And Reconstructor is also the software engine adapted by Geomax, Stonex, and Teledyne. So once imported the data, we have seen that the software automatically can register all the scans together without using any kind of target, and then proceed with the output extraction, such as the full 3D model, the cross-section creation, the orthophoto, as you mentioned, and then the elevation plans and comparison analysis, and then the 2D drawing extraction, and even more, of course, depending on your need. I'd like to ask you guys one thing. Can you explain a little bit much more in details which kind of output you were able to extract during your project?
Yes, by combining all this data that we are talking about, we were able to create this complete 3D model of the environment. And from here, we could easily divide the model into smaller sections where we could go further into the material. And when we had the desired environment, we extracted these cross sections with the help of the mining add-on, and it helped us to extract a huge number of cross sections. We are talking about 500 plus, as we mentioned. And when you use this add-on, you get you generate the orthophoto, and you make a slice of the point cloud, and you also generate some vector graphic based on your cross section. But what we used the most was the orthophoto that we put measurements on, and the slices of point clouds.
Okay, so thank you very much for this description of the output that you had reached in the software. So I think that this workflow description has been pretty useful to really understand and enter inside the concept of the project. And I think that you have well underlined some of the key functions of Reconstructor, that have supported you in creating a customized and smooth pipeline. So let's now try to experience some of those functions. So the data have been imported into Reconstructor, subdivided in blocks of around 150 and 300 meters length. And Reconstructor has a very smart and clever project structure that you can always take under control in your screen, and that enables to organize the data in groups. And this is definitely helpful in case of a huge project. Each group can contain multiple and different objects, such as clouds, 3D meshes, sections, planes, all the objects both imported and created in Reconstructor itself. And as you know, guys, in Reconstructor, you can import, as we have seen, several objects. The cloud then have been merged together in a cluster, and the user can select the desired layers and the subsampling, okay? In this way, you can create a single cloud merging data coming from different sources very easily. And what I like is that you can set the resolution of the new cloud. Reconstructor support different layers creation, and in general, point cloud and any kind of item in Reconstructor have a set of properties. And to benefit of the layer visualization, you just change the color map option and play with the light setting option 1. And what I like most, for example, is this ambient occlusion that simulates the shading effect underlining the edges visualization. So let's jump back to our function that we have experiencing in Reconstructor. Guys, you mentioned that you verify the status of the as-built, and to do that, you have compared different scans together. May I ask you, how did you run this comparison between the scans?
Yes, previously when we had 2 scans of the same environment in the same coordinate system, we visualized them and put them on top of each other with 2 different colors. In this way, we could inspect the visualized point clouds and see if there is any deviation. But this was before the cloud-to-cloud inspection tool was available in the software. After this tool was presented to us and we tested it out, it has become the main source of inspection that we use between clouds. So in this way, we put 2 clouds on top of each other and you recolorize one of them to show deviation between the point clouds. So what you see in the picture here is a part of the tunnel that we did such inspection on. And everything that is green has not moved between the 2 point clouds. But if you see, the tracks on the right are colored blue and the tracks on the left are colored a bit yellow. And this indicates that the tracks on the right have decreased in height, where the tracks on the left have increased a little bit in height. And it's a really great way to just visualize a tremendous amount of data and get a good inspection of it.
Thank you very much, Soroush. Yeah, I remember also the webinar that we have spent together, not with me, but with our senior engineers about this inspection, because I think that this inspection is a smart Reconstructor tool that enables to compare 3D models. And we have experienced with you, with you, a usage of this inspection, but I think that the usage of this inspection is really multiple, because you can run as built, as design comparison. So if you have, how to say, a reference model, for example, a beam one, you can compare the as built and as designed. You can compare the models in order to extract the 3D geometries variation in time, as we have done here, or better, as you have done here. And we can also run an analysis in terms of verticality and horizontality, just considering a reference plane to inspect your model. And the result can be displayed in 3D, as Soroush has shown you in the slide before, with a customized color layer that, of course, can be customized as you like, depending on what you are looking for. And the other thing is that you can also export this kind of information in a sort of in a PDF report that can underline all the differences that can be extracted. You can personalize this PDF. It has got an histogram inside, so it really can be a complete also document to deliver. And I am now glad to move to, in my personal opinion, one of the coolest results that has been reached out in this project. I try to summarize briefly, the workflow of this result, and then I will leave the floor, of course, to Peter and Soroush, who can explain and show you a little bit more about this. So, starting from the Reconstructor elaboration, the cloud registration has been done. Then, after register the scan, the point of interest has been extracted, has been defined, and from this, the cross-section and the orthophoto has been extracted. All this information has been then imported to CAD, and here has been created the 3D model, okay, from the section, and then the new element integration in order to check how the new element, in order to check the feasibility of the integration of the new element inside the existing environment. And then this complete model has been exported in OBJ, for example, in this case of the project. But let me jump and leave the floor to Peter and Soroush in order to let them explain a little bit more about this output.
Okay, so here we can see there are two trains drawn in here, the outline of the trains, and here we can see the details of the mast with the cantilever a further bit down. It is the right, it is scaled according to reality, and we find that when you visualize stuff to this extent, it is very useful for the guys who is going to either draw the new customized masts or the guys who are going to mount the mast and stuff like that, because it's so visual. And compared to a point cloud, obviously, this is much more easy to digest. So we have found great value in just the visualization of it, but obviously also for the project itself, it's very easy to take these CAD models further into CAD drawings of the whole tunnel and the project.
And we could also say that it has been a real pleasure to work with Poweron and their technical drawers over there, because they're really highly skilled. So it has been a pleasure for us.
Yeah, from what we have seen, I mean, about this project, of course, there were different kind of technical person, you guys, and also the guys from the guys who work on this CAD project, and of course that everyone has got its own skill, its own sensibility, of course, and merging together all the knowledge, all the skills, I think that is really what can make a project like this being winning. And I just ask you very briefly to comment on this slide, because, for example, it's something that I have learned also from my personal, learning. And if you want just to spend a few words about what we are looking now, that is one of the, I think, of the new elements that have been integrated in this project.
Yes, on the picture here you can see it's from the workshop of Povron, and they have partly assembled the mast. They need to consider the weight of the construction because it's going to be lifted up and mounted. So it's partly assembled. Almost every mast is customized to its position inside the tunnel. And this is a new great thing, because earlier they used one shape for all of it, and they cut it on site later, which is very time consuming and expensive. But now it's customized thanks to the 3D. And it's very important that you tag every case with the right mast number, or it will be messed up.
Yeah, really, definitely. So I think that this is really one of the core of this project, because in this way, the possibility to work with the 3D as a support in order to customize this kind of element, it's very important, not only for the construction itself, but of course also for, I think, the complete project in terms of budgeting, because as you mentioned, of course, in this way you can, how to say, pre-assembling and pre-project and pre-build up this kind of element after, of course, checking the feasibility. So it's, I really thank you very much, guys, because I think this project, it's interest not only because you have described how did you work, what have you used in terms of technology, hardware and software, but especially because also you gave a lot of operative input, in my opinion. So what I ask you now is, could you please summarize the project key points? Yes,
I would say that based on the input we have gotten from all the other involved parts, is that the job has been done faster and has been more accurate, because when you base it on point cloud data, it's kind of as real or as like reality as possible, and the ability to digitally visit the tunnel obviously is much safer and less expensive. So I think time, security, and money saved are three important elements. And maybe you, Soros, you have some tips?
Yeah, those are like the most important elements, but for us as a company, it has also been great to have access to a lot of the point cloud data from several inputs, and also having multiple scanning intervals of the tunnel. This has helped us a lot to make sure that what we deliver is up to date with the real conditions. So multiple scanning is really great if it's possible. And then since it was such a heavy project for us, we had to make sure that all the control measurements, all the verifications, everything that was possible to do had to be done.
Yeah, thank you. Really, thank you very much, Soros and Petter, to have, describe this project, but also, to have underlined all these, how to say, all these key points that I think really summarize pretty well what a 3D laser scanning project should achieve. Being faster, more accurate, increase the safety, of course, and of course also taking under control the budgeting. And on the other side, as Soros explained, in terms of a company, of course, working, having the chance to work and to integrate, and also being clever in deciding how, which kind of technology use, how to merge, how to integrate, what to extract. I think that it's definitely very, very, very important. So thank you very much. And let's just quickly have an overview about Reconstructor, because I think we have mentioned a lot of things. Reconstructor is the market-leading point cloud processing software that is used worldwide and composed, as we briefly mentioned, main core package and 3 add-ons. The different modules provide the widest processing option for 3D laser scanning jobs in engineering, construction, surveying, mining, architecture, and many other applications. I think that Reconstructor takes users from start to finish and can create all the deliverables that you might need. It is fully integrated with third-party software such as Autodesk Recap, EdgeWise for modeling, Micromine if you work in mining industry. And Reconstructor project can be easily distributed over the web, but also by Sim2, Faro WebShare, and 3D Usernet. The base module includes a smart automatic wizard to import, filter, automatically register your scans without target, and then several clouds editing functions support the user in create lightweight and clever organized 3D models. Then a set of easy-to-use tools support the extraction of a vast array of deliverables like 3D models, reports, cross-section, movies, inspection maps, orthophotos. So all elements that we have seen together in this smart project explanation. Let me add that those deliverables can be enlarged by the mining add-on that Petter and Soroush have mentioned and that have used. The mining add-on provides dedicated tools for topographic surveys such as dam creation, profiles extraction, crest and toes, and cut and fill volume computation. If you have then to enrich your 3D models texture, it is possible to add the color add-on and external pictures like spherical, perspective, thermal one, we can say mostly any kind of pictures, can be dragged onto the point cloud and applied to create high-resolution texture models. And last but not least, Reconstructor can be enriched by the Aeron add-on that is dedicated to process and manage our JEXEL Aeron portable mobile mapping 3D data. Schools and universities can benefit of the entire Reconstructor family that we have just seen by some very special commercial conditions. If you might need more details on that, I'll be glad to provide further details, of course. And do not forget that you can freely share and navigate your Reconstructor project with colleagues and clients. You can visualize and investigate your 3D project using the Reconstructor viewer. But that's not all, because if you want to share your 2D maps, you can use the Go Blueprint viewer. You can visualize and investigate orthophotos, X-ray orthophotos, and blueprint. This Go Blueprint viewer can be installed both on your workstation or on Microsoft tablet, and you can take linear and angular measures, as well as calculating areas and volumes. You can download both the viewer from our website, and you can play with them. I think that we have almost reached the end of today's webinar. Thanks to Soroush and Petter our friends from WIESO, we have experienced some of the function of Reconstructor. So a complete set of tools to process point cloud and meshes that increase sensibly the productivity and makes working on your 3D data more enjoyable. So I am used to saying that Reconstructor has a little for everyone. If you guys want to test the Reconstructor, you can try the 30 days free demo with all the functionality activity. And of course, if you want also to buy, you can access to the monthly license on our store or contact us at sales@jaxel.it for a quotation. Do not forget to mention if you belong to a university. And the Jaxel family is spreading fastly around the world. So if you want to be part of it, contact me and we will evaluate the cooperation feasibility. Now, I think that we really come to the end of today's presentation, but before leaving, we still have some times for Q&A that are, that there are a lot. I first of all want really to thank Soroush and Petter for joining us, giving this opportunity to experience this wonderful project. So Petter and Soroush, thanks a lot, guys, for sharing this amazing project with us and your experience.
Thank you very much.
Thank you.
Okay, so I think that we have now time for Q&A. Sorry, I am just reading. Guys, I have a question for you. What is the 3D laser equipment used for this railroad project?
It's as we said, it's different systems, but the mobile mapping system was something called ViaTech, but I don't know the specifics for it, because we just hired a land surveyor company, was hired to do the scanning. But the terrestrial scanners we used was RTC 360. And the one from the plane, I really don't know.
Okay. If perhaps the attendees would like to have more information, we can reply also with the details. Or guys, of course, if you have, something more to ask to Soroush and Petter, this is the right moment to do in real time. But of course, they can also get back to you later on. I have another question for you guys. What is the size of the data? I think that is what is the size of the point cloud that you have worked with, I think.
Yeah, the raw data that we imported, it was around 80 gigabytes, I believe. But thanks to the tools in the software, you can subsample the data. So we did a lot of subsampling for the different parts. But I think the file that we have in Reconstructor for this project is about 500 gigabytes. Then you have like your orthophotos, all the extractions, double ups, duplicates. I think it was about 500 gigabytes.
Okay, and another question for you. There are a lot for you guys. The time for processing all the data, I think, from importing to register and the processing time, we can say, before reaching the deliverables, and then also if you can mention after, extracting the deliverables.
Oh, it's so divided since it's different systems, and so we processed some of the terrestrial data ourselves, and that was like a day for 500-600 meters of scanning. But the mobile mapping system, I think it was somewhere around a week from when they were finished scanning and when we received the material. I think they used a week, but I'm not sure exactly in hours and minutes.
Yeah, no. I think that a general idea it's more than enough.
Yeah.
Thank you. Yeah, because of course, I mean, these two questions are hard to say, pretty clever, because every time people ask, okay, but I mean, which is the dimension, the size of the data? Because at the end, we have to import and manage this data on computer, okay? And then, of course, also, which is the processing time? So, thank you very much for this information. And someone asked, you have scan, I'm sorry, I am reading, from portable scanner, static, and so on, how you will match both at the same time. So I think that the guy here is interested to know how did you merge all these different data together at the same time, I think.
Yeah, that's like the magic in this business. The land surveyors provide coordinate systems, helps a lot. But I can also say that when we scan in a local system, we use Reconstructor to cloud align the point clouds. And this is a really nice option to have. Because if you have the money to hire land surveyors each time, that's great. But usually you need more scans than you can afford to hire people to do. So if you have one good scan that is in a coordinate system that is usable, you can scan locally and align it in the software.
Yeah, using the cloud to cloud, normally, you need, how to say, an overlapping between the clouds that also could be not so huge, around 25–30%. And so it's really, speed up the registration process. Yeah. And another question, good job. So congratulations for this job. Can you provide us with information about hardware and software for LiDAR? Yeah, I think that you already have mentioned about the hardware that you used. The software we have described, the workflow inside the Reconstructor. Then, of course, there is also what come, I think, after Reconstructor, so the modeling part in CAD. I don't know if you wanted to spend a few words about this. Perhaps people are also interested in this.
Yeah, Poveron has specialty in AutoCAD Inventor. That's where they draw the CAD models. Yeah, exactly. Yeah. Okay, so I think that we have reached our time. Let me see. In case you might have other question, other doubt, of course you can contact us. That's not a problem. Once again, really thank you very much to Soroush and Petter for joining us today and explaining this amazing project. Before leaving, just a few information. Do not forget to follow us via our channels, so you could be always updated about event, activity, and news. If you are interested also to get more information about the project, about our JAXL product, we are more than pleased to get back to you. We can also organize other webinar, just specify it in the opinion survey. I remind that the movie will be shortly uploaded also on our channel, but anyway, you will receive the record of the webinar. So
once again, thank you, Petter and Soroush, and also thanks to our attendees today. And we look forward to see you in the next event. So thanks again, and we hope that you will have a great day. So thanks a lot, Soroush and Petter, and let's keep in touch and stay tuned for the next event.
Yes, thank you.
Bye.
Bye-bye.
Ciao.
Ciao, ciao.